$217 million flying fortress built for the commander-in-chief, yet one that nearly failed before ever lifting off the White House lawn. This is the engineering of the marineone helicopter, an absolute masterpiece of modern aerospace engineering. Behind this incredible machine is a rocky development history that nearly kept it grounded for good. Early testing revealed serious, unexpected hiccups. The aircraft scorched the very lawn it landed on, failed critical secure communications trials, and was even labeled as not operationally suitable by the Pentagon. Yet when you strip away the political red tape, this chopper is the only thing standing between the leader of the free world and a very long commute. Built from the bones of a reliable commercial workhorse, it has been pushed to the absolute edge of what a modern helicopter can handle. To see exactly why this happened, we need to look at what Sikorsky originally built. To understand the sheer scale of the machine's problems, we have to look at what it was based on. The original Sikorsky S-92 was designed to do one job incredibly well: haul oil workers back and forth from offshore drilling rigs in terrible weather. The requirements were incredibly straightforward: transport the crew safely, keep maintenance costs low, and land reliably. Civilian airlines around the world trust the platform because it gets the job done without any fuss. It was built to carry up to 19 passengers with a standard takeoff weight of roughly 24,000 pounds. The airframe was spacious, efficient, and well-tested in real-world scenarios. But then the United States Marine Corps took that same commercial frame and started adding heavy defensive equipment. The goal shifted from simple utility to maximum survivability, pushing the airframe far past what it was originally drawn up to do on the blueprint. The weight increase pushed the airframe straight into a complicated and dangerous territory. When you turn a standard transport helicopter into a presidential carrier, you have to add substantial weight. To keep the passengers safe, engineers wrapped the passenger cabin in heavy-duty armor plating. Every single pane of glass was upgraded to thick, heavy-duty ballistic material capable of stopping high-velocity rifle rounds. This added immense weight to the upper structure of the cabin. Under the floorboards, the fuel system was completely overhauled. The standard tanks were pulled out in favor of self-sealing units designed to close up if punctured, stopping jet fuel from spilling into hot engines and causing an immediate fire. Then came the classified communication suites, radar jamming gear, and defensive countermeasure dispensers. When the final checklist was drawn up, the aircraft weighed nearly 27,000 pounds fully loaded. That was an increase of 3,000 pounds over the civilian version. And as any pilot will tell you, adding that much weight to a rotary aircraft completely changes the physics of flight. All that extra strain generated intense heat and vibration. 3,000 pounds might not sound like a big deal when talking about a massive transport plane, but it was a major challenge for a helicopter. A standard airplane can just use a longer runway or burn extra fuel to get off the ground. But a helicopter relies on pure vertical lift. It needs to take off vertically, hover over a small area, and land safely on a manicured lawn. Pumping that much extra weight into the frame means the rotor blades have to bite through much more air just to stay in the sky. Suddenly, a margin of safety that used to be comfortable becomes razor thin. The engines have to run much closer to their maximum limits, producing more heat and using more fuel just to keep the bird airborne. It was the reason why the early models scorched the White House lawn during their initial trials. The system was simply working too hard to overcome the downward pull of gravity. The weight forced the downward blast from the blades to hammer the ground. It generated so much heat and pressure that it literally scorched the grass. The flight crew and mechanics watched the instrument panels with real concern, knowing every single pound of armor forced the hardware to work harder. Those massive spinning blades had to spin faster just to keep the aircraft in the air, pushing the transmission and engine cooling systems way past their normal limits. Keeping all of this running without breaking down gave the maintenance crew a massive headache behind the scenes. The added weight also pushed the entire drivetrain to the breaking point. The main rotor transmission, which was designed to transfer smooth, predictable power from the engine to the blades, now takes a pounding with every turn. Each component was subjected to higher torque and vibration. Sikorsky's original design was meant to log thousands of flight hours with minimal stress, but hauling 3 tons of extra defense gear alters that balance. To keep the helicopter safe, engineers had to build in multiple layers of redundancy. There are backup flight computers, dual hydraulic pumps, and redundant electrical wiring everywhere you look. There cannot be a single point of failure in an aircraft designed to carry the commander-in-chief. The mechanical strain meant that parts wore out much faster than they did on standard commercial aircraft. After every 1 hour of flight, it required significant maintenance to ensure reliability. Engineers would have to work around the clock to reinforce the gearbox and ensure that the rotors could handle the heavy workload during unexpected maneuvers. This made it a constant balancing act between keeping the heavy armor intact and preventing critical parts from overheating. This complex engineering hides behind a highly familiar exterior design. If you happen to watch Marineone take off from the South Lawn, it was easy to mistake it for a standard commercial transport helicopter. The overall shape of the fuselage, the nose cone, and the 4-blade rotor system look almost identical to the civilian version flying out of remote airports. Even the color scheme, the dark green bottom paired with the bright white top, is a nod to history, used on the presidential fleet since the Eisenhower administration. But beneath that simple paint job was a completely different machine. Every single rivet, wire, and engine part has been beefed up to handle the extra weight and heat. It was a striking example of form following function, keeping the classic look while hiding a completely redesigned interior. So, while a casual observer sees a straightforward and reliable workhorse, the internal layout was a totally different story. It's a high-tech command center. Balancing the weight was another massive headache. The team had to tweak everything just to keep the chopper steady when it lifted off or touched down. They spent countless hours making sure the heavy armor didn't throw off the entire center of gravity. All that heavy lifting eventually paid off, bringing in a completely new era of safe VIP travel for the president. Despite its rocky rollout and initial Pentagon concerns, the BH-92A is now fully integrated into the presidential support mission. The aircraft successfully navigated its early communication and heat signature hurdles to become one of the safest transports in the sky. This transformation shows just how hard it is to balance civilian efficiency with heavy military protection. The machine is a testament to the engineers who managed to make a heavy transport helicopter lift off without losing performance. When you see it fly off toward Andrews Air Force Base, you are not just looking at a fancy ride, you are looking at an aircraft pushed to its absolute limits to protect its passengers. The ongoing maintenance and constant upgrades ensure that the chopper remains ahead of emerging threats. The platform proves that even the most over-engineered and problematic projects can evolve into reliable assets with enough dedication and technical refinement. The Marineone program now stands as a symbol of resilience, showing that complex challenges can be solved through innovative engineering. Would you consider this over-engineered flying fortress a triumph of modern engineering, or a prime example of overcomplicating a perfectly good design? Let us know your thoughts in the comments.